Hi and welcome to the video training of JavaScript. In today's video training we will be learning about 10 JavaScript array methods to boost your code performance. With lots of instance methods, the array API is one of the biggest in JavaScript. At first it can be overwhelming. It is important to invest some time in getting familiar with it. Methods like map and forEach are widely abused. Instead, by using the right interface, you can make your code faster, more efficient, and more readable. In this video, we will be looking at the 10 more useful instance methods of the JavaScript array object and where they shine. The first one we are going to look at is Splice. If you want to make a copy of an array by a start and end index, you might want to use Splice. This method is a pure function, so it won't have any side effects, nor mutate the target array. The Splice method returns a shallow copy of a portion of an array into a new array object selected from start to end. End not included, where start and end represent the index of items in that array. The original array will not be modified. This method is helpful when you need to build subsets of an array and don't want your target array mutated. So let's look at an example. I'm going to use Google Chrome. I'm going to create an array. Const array equals 1 2 3 4 5 6 7 8. Okay, we have an array. Now if I say console.log array.slice 2, I'll get 3 4 5 6 7 8 because it has sliced the first two index element, that is 1 and 2, from the array. Now if we want to give a start index and the end index to the Splice method, we can do so by giving the start 0 and end 3, and it gives us 1 2 3. So it gave us the first three elements from 0 to 3. Similarly, if we want to print the whole array, just use console array dot and we got the 8 elements. So this is Splice function. The next one we will be looking at is Splice. This method is similar to the previous one, but with one big difference. It will mutate your target array. It is useful when you are dealing with a big array and you need to be partially consuming subsets of it. The Splice method changes the contents of an array by removing or replacing existing elements and or adding new elements in place. Let's execute the previous example but using the Splice method. We can observe how the target array was mutated and how it's blank after the two execution of the Splice method. So we already have an array of 8 elements. So this time I'm going to use console.log array.splice and I'm going to give 2, and this gives me the 6 elements, taking out the first 2 elements. And now I'm going to use array.splice and giving 0 3, and this gives me 1 and 2. And now if I print out the array, I get an empty array. So that's how Splice function works. The next one is includes. The includes method is a tool to check whether a certain element is present in the array. It returns true or false. It doesn't accept any equality functions, so it will match if the object primitive is contained in the object. For performance tuning, you can pass the starting index as the second parameter. That index can be negative or positive. If negative, it will check the last x numbers. So let's say we have an array 1, and we have 5 elements in that array. Now I'm going to call array dot includes, and I'm going to pass 3. It returned me false. Okay, the next one, array dot includes, it returns me false because use the array. It should have returned true. So array 1 dot includes 3 gives me true. Now if I say array 1 dot includes 3 comma 4, it gives me false. And now if I say 3 minus 3, it gives me true. And the last one is 2 minus 2 gives me false. So that's how the includes method works. The next one is sum method. The sum method is similar to the includes one. It doesn't mutate the array either. The difference is that sum provides an equality callback and includes relies on matching primitive objects. Another difference is that it doesn't let you customize the starting index. Let's look at the syntax. Array.sum, callback element, index array, and at the last argument. Let's say we have an array and we want to check if any of the items is greater than 10. We can't use the includes method for that scenario. Let's see how intuitive is to do that with the sum method. Let's declare a new array and call it array 2, and I'm going to add 5 elements. This array 10, 30, 50, 10, 5, semicolon, and now I'm going to say const greater than 10 equals element equals element greater than 10. Okay, and now I'm going to say console.log array.sum greater than 10, and it gives me false. It should give true, but it gives me false because I used array. Let's give it array 2 and it gives me true. So that's how the sum function works. The next one is every function. This method works on a similar concept to the sum one. However, it will return true only if all the elements match the criteria. The criteria are given by a callback function, just like the previous method. The every method tests whether all elements in the array pass the test implemented by the provided function. It returns a boolean value. The syntax is identical to sum. Array.every, callback element, index array, this arguments. Let's use the previous example. Let's say we want to make sure that all elements are greater than 10. As the interface arguments are similar, we can use our previously declared greater than 10 function. But this time we are going to use every method instead of sum function. And it gives us false. So this is basically the difference between sum and array, sum and every function. The next one is the find function. The find interface is useful if you want to look for a precise element. It is common for people to forget it's there and do some imperative find methods when you can use the built-in instead. Once again, the syntax is nearly identical to the previous methods. A.find callback element index arrays this element. This will return the first item that matches the condition, or undefined if nothing matches it. Be mindful when there is more than one item matching the callback criterion. Once more, we can use our previous example. Running our greater than 10 combined with find will return the first element that is greater than 10. So let's run the previous example, but this time we are going to use find instead of every. So this time it returned 30 because 30 is the first element in the array that is greater than 10. If you are only interested in the element's array position, it's best to use the find index method. The next function is the shift method. The shift method is simple and intuitive. It just removes the first item from the array and returns it back. Be careful as it will mutate your array object. How is that different than the pop one? The pop interface will remove and return the last element of the array, whereas shift will remove and return the first one. Both do mutate the array index. So let's create an array foo constant foo equals 1 2 3. So we have 3 elements in the array, and say constant x equal foo dot shift, and this will assign 1 to x because 1 is the first element in the foo array. Now if we console.log x or foo, we get 2 and 3. This is ideal for FIFO implementations, that is first in first out. You can queue your items in an array and pull the next one from the queue using shift. The next one is Unshift. This method is the complete opposite of what we have seen previously. Instead of removing an item, it adds it to the start of the array. The Unshift and push methods differ in the same way as shift and pop. Unshift will add elements at the start, whereas push will add them at the end. Both do mutate the array. So let's say we have an array foo2 with 3 elements, and I'm going to call constant y foo dot unshift, and I'm going to say 4 5 6, and x will now have 6 since it's the length of the array. So if I say console.log foo2, I get 1 2 3. Foo dot unshift. Okay, sorry. This was foo dot unshift. And now if we console, we have 4 5 6 1 2 3 6 elements in the array. So that's how Unshift works. The next function is the flat map function. Before directly jumping into flat map, let's understand the flat method. The flat method creates a new array with all sub-array elements concatenated into it recursively up to the specific depth. It is the best choice for when you need to flatten an array. It accepts an argument of the depth in which you want to flatten your array. By default, it is 1. Let's check an example to see how your code becomes more readable and concise by using the right method. So let's find an array. We call it Q, and to define a multi-dimensional array 1 2 array 3 4 5 6, and so our array is Q. Now if I say q.flat to, so it returned me the whole array and merged all three arrays into one. So it is equivalent to x.reduce as well, account value array dot is array value. So we are now ready to dive into flat map. This method is like shorthand combination of map and flat. The flat map function returns a new array formed by applying a given callback function to each element to the array and then flattening the result by one level. It is identical to map followed by a flat of depth 1, but slightly more efficient than calling those two methods separately. Let's see an example. So if I decide to create an array R equals 1, 3, 5 and 7, and I say x dot flat map, f is small, flat map xr equals x r comma r plus 1 this is also R. Okay, I forgot to add the closing braces. Okay, now we have the all elements is equivalent to x dot map x arrow function x plus 1 dot flat, and is also equivalent to x dot reduce mount value arrow function account dot on get val plus 1. We are able to express more in one function without any performance penalty. The last one is the reduce function. The reduce method is a powerful and flexible method. The concept is a core piece in the Redux management library. The reduce method executes a reducer function that you provide on each element of the array, resulting in single output value. You can simulate many of the array interfaces by using reduce. The fact that you can doesn't mean you have to, as the built-in methods are more readable and efficient. For fun, let's create a map equivalent using reduce. So function map have two parameters, item and cb. Return items.reduce account item and account cb item. So if we create const increase 1 equals item to then item plus 1, we call the map function map 1 2 3 increase by 1 outputs 2 3 4. Final thoughts: there are plenty of array methods in JavaScript's array API. It is important to have a deep understanding of each of them. As a summary, when using arrays, you need to ask yourself, is this the most suitable method for any particular scenario? Do I want my object mutated or not? Using the wrong method might translate into a performance or memory drop. On a small scale, the benefits are less obvious, but once your application data grows, you will start seeing the performance gain. As software engineers, it is our responsibility to have an eye on performance rather than just making things work in a brute force fashion. If you liked this video, don't forget to subscribe to my channel. If you need any help, feel free to contact me at umehmood@gmail.com. Visit me at my LinkedIn address or my Twitter handle. See you next time with a new topic in JavaScript.